morning, we're going to be talking about laws of what indices. That's what we're going to be discussing today. And then you need to understand that when you have something like this in the what in law of indices, we call this base. You need to understand that, and we call this power. And the first thing you need to understand. Another thing you need to understand is if you have, for example, 2 raised to the power 3 over 2 raised to the power what? 2 raised to the power 5. When you discover that they have the same base, they're having the same base, what you can do, you write one of the base. Then 3, then there's plus here, there's invisible plus, there's invisible plus. The time it's coming up, we have division become minus plus 5. And include the brackets. Why is this minus coming up? Because it is division. Therefore, you have 2 raised to the power 3 minus times plus will give you what? Minus 5. And that basically will give you what we have 2 raised to the power what? 2. 2 raised to the power what? Minus 2. That will give you 2 raised to the power 2. Usually when we divide, we subtract the exponential of the what? Equal bases, where the bigger exponential is same. And then this particular can turn this, you need to understand that this particular thing you can turn to inverse. Is the same as 2 raised to the power what? 2. Yes. Therefore, just like you have x raised to the power minus 1, it seems as what? 1 over x. As in, what has happened? The power sign will change from minus what? To plus. That is just the case, and now what has actually happened. We need to understand that as well. Then, for example, you can have another thing. You can have 2 raised to the power 5 over 2 raised to the power 2. Then you have 2 raised to the power 5 over 2 raised to the power 2. Now the same base, just have to pick one of the base, which is 2. Then have 5. Then this sign means what? Minus the invisible as plus 2 there. Therefore, basically, this should be 5. Then when you have plus, minus times plus will give you what? Minus, and you have 2, and this will give you 2 raised to the power what? 3. And that will give you 2 raised to the power 3. Now, but basically what we're saying, let's say, is when you just have to understand, for example, when you have times 1 over x raised to the power minus 3, this one is into as x raised to the power what? 3 over 1, because 1 over 1 over 3, that is when I have 1 over minus 3, such as this. Then when you have x raised to the power what? Minus 3, x raised to the power minus 3, such as what? 1 over x raised to the power what? 3. Just have to understand the inverse. When you have x raised to the power minus 3, same as 1 over x raised to the power 3. Basically, if you have x raised to the power minus 1, that's what I've said before, it should be 1 over what? X. That's what we're saying. But when you have 1 over x raised to the power minus 1, automatically this will give you what? X. Yeah. These are things you need to understand first. That when the power is minus, you can have as 1 over, you can have it as 1 over x. Basically, if you have, like I have 2 raised to the power minus 2, I can have it as 1 over 2 raised to the power 2. What will happen to the power? The power will change from minus to plus. And that will happen here. It's changing from minus 1 to what? Plus 1 when you have it over 1 over x raised to the power 1. Yeah, but when you have 1 over x raised to the power minus 1, that will give you what? X. Basically, what it means is, what this thing simply means is you have 1 divided by what? X raised to the power minus 1. And this particular one, we know that this same thing is 1 divided by 1 over what? X. Then it must be in changing the sign, x will go up while 1 will come down over 1. Basically, that will give you what? X. Therefore, what we are saying is 1 over x raised to the power minus 1 will give me x, meaning if I have 1 over 2 raised to the power what? Minus 3, automatically this will give me what? 2 raised to power 3. That's what we're saying. The power is what? Changing. Then when you have 2 raised to power minus 3, then it's same as 1 over 2 raised to power 3. That's happened. Turn into what? From minus to what? Plus. This kind of thing you need to actually understand when it comes to what indices. The power will change when you what? When you make it 1 over that particular what number. That is the first thing, and basically it will be talking about more of this particular thing. Is we are going to achieve all these particular what learning objectives. Basically, at the end of this chapter, you should be able to require use the law of indices for multiplication, division, and zeros, and what reciprocal, which we've been talking about. Simplify expressions that contains products of indices and partial what indices. Then solve simple equations containing indices. Then should be able to express and interpret numbers in standard what form. Find the logarithm and what anti-logarithms of numbers greater than 1. Then use of what? Use of logarithms to solve problems. Basically, this is what we're going to be doing. I've explained it for you. Yes, just the same thing as what I've explained in the beginning for this particular class. Yeah, but another thing you need to know is it's what I'm bringing out for you. The first thing is anything raised to power 0 should know that we give you what? 1, where s is not equal to what? 0. You can't have 0 raised to power 0 giving you 1, no. Yeah, but if it is 5 raised to power 0, s raised to power 0, automatically it's going to give you 1. Then you need to know that the square root of if you have 9, if the power is half, basically what it means is roots, and the root of 9 will give you plus or minus what 3. Meaning if you have 4 raised to power what half, 4 raised to power 1 over 2, same thing as what root of what 4. And basically I need to know that root of 4 is plus or minus what 2. Then if I have 8 raised to power 1 over 3, then I need to know basically that this is talking about cube roots of what? 8. And basically it means what can you multiply in 3 times that will give you 8? I think 2 times 2 times 2 will actually give me what? 8. Therefore, the cube root of 8 will be what? 2. Because you can multiply 2 in 3 times to give you that what? 8. Then if you can have, okay, let me say I have 16, 1 over 4. 1 over 4. This simply means fourth roots. This means fourth root of what? 16. When we're talking about fourth root, what can you multiply in 4 times that will give you what? 16. I think 2 times 2 times 2 times 2 will give me what? 16. Because 2 times 2 is 4, 4 times 2 is 8 times 2 is 16. Automatically, fourth root of 16 will give me what? 2. But basically, you just have to understand this before I go deep. Then you need to understand as well that the bracket of minus any number raised to power 2 will give you that twice that particular number. Therefore, if I have minus 2 squared, automatically it's going to be what? 4. What I get 4 is minus 2 times what? Minus 2. Automatically, minus times minus will be plus. Then 2 times 2 will be what? 4. Basically, that's what it means. But it's totally different from when you have minus root what? 9. Minus root 9. So automatically here root 9 is 3. Therefore, we're taking one side of that particular side. They said, for the root you should have got plus or minus. But in this particular case, we are taking the plus side of the roots. Therefore, and this sign in front will take the shape. Therefore, root of 9 will be 3. Therefore, but because of this minus, we make it what? Minus 3. It's totally different from when you have root of 9. Root of 9 will be plus or minus 3. Just like, but you need to know the reason why this is because they want this as root of 1 over 4. And s raised to power 1 over n, which is, for example, 16 raised to power 1 over 2, for example. That will be n with n x, which is simply means plus with 16, for example, to stand for one number only. And this particular one stand for another word, stand for one number only. Therefore, but if s is standing for one number only, therefore basically I can say root 9 is 3, I can say root 4 is 2. So I'm taking one side of that particular number. But if I have s squared equals to 9, I have to find s. Basically if I have s raised to power 2 equals to what? 4. Then to find s, what can I do to remove this square? What I can do is to take the square root of both sides. If I take the square root of both sides, this cancel, this will cancel this square root. This power 2 will cancel the square root, giving it x. Then what will now be the square root of what? 4. The square root of 4 will be what? Plus or minus 2. It's totally different from what is root 4. That is taking two sides of the what? Of the value. The two sides of the number. Meaning it's taking x can be what? Plus 2, or x can be what? Minus 2. Taking two sides fit. You need to note which is totally different from what is the square root of 4. For the square root of 4, I can say 2 categorically. And when they say what is the square root of minus 4, yeah, I can say categorically is what? Minus 2. Another thing you need to know that student tends to what? To forget what the word logarithm really means. Emphasizes the following. Emphasize what? The following. In numbers, if 10 raised to power 2.301 is equal to what? 200. Then log 200 to base 10 will give me this. You have to understand what we're talking about there. The log 200 to base 10 automatically is going to give me what? This 2.301. And if I have to turn it back, according to the logarithm, if I to turn it back, this 200, this log 200 to 10 equals to 2.301. You need to know this base of the logarithm, and this is a number itself. Log this 200 to base 10 equals to this. Therefore, this base when raised to power, the answer, you have 10 raised to power, what you have automatically will give me what? 200. And log 200 to base 10 will give me this. Therefore, how do I get 200? Is by taking the antilog of 2.301. And if I was to take the antilog of 2.301, we take 23 under 0 from 1. And then in works, log base 10 of 200 is the exponent of what? So which 10 must be raised to give 200. 10 must be raised to give what? 200, which is the number. Therefore, you need to understand. And basically, what we're saying here is a very simple thing. If I say log 4 to base 2 is equals to what? 2. Basically, what we're saying here is 2 raised to power 2 should equal to what? 4. Meaning if I take this, if I take the in base 2, this particular thing, what I'm saying here is 2 raised to power 2. Automatically, in this particular case, I can make this 2 to be s because log 4 to base 2 is equals to 2. Fine. Simply means, according to what we have, simply means we are taking the anti-log, but it's not in base 10, it is in base 2. Therefore, you might just say, okay, since it's in base 10, let's make, how did they get this? And say, okay, let's make something like this, log 4 to base 2 equals to what? X. In this particular case, this is what? Base. This is the value that is equating to this number. Therefore, we just say number which is 4 equals to base to the power of the value outside. And in this case, 4 is equal to 2 raised to the power of 2. I want to equate it to that what? Base. Therefore, base can cancel base, then x will automatically equals to 2. Therefore, what they are saying here is log 2 to base 2, which is same as 4. Log 2 raised to the power 2 to base 2 is same as taking the power to the front, saying 2 log 2 to base 2. And when you have log with the same base, it give you 1 automatically. When you have log 2 to base 2 will be 1. If it is log 10 to base 10 will be 1. Automatically have 2 times 1, that will give you what? 2. Basically, what we are saying here is a very simple thing. We are saying in Word, the log base 10 of 200 is the exponent to which 10 must be raised to give that 200. Students tend to forget what anti-log means. It's if, for example, 10 raised to the power 2.301 is equals to 200, it means we are taking the anti-log. The anti-log means that we want to know what the answer of this is. That's basically what it means. We want to know what this particular answer is in base 10. Therefore, you just check 2301. And students tend to forget why they had logarithm of numbers. If it is multiplication, multiplying the numbers, if they multiply the numbers, and why they subtract logarithm of numbers, basically, if they divide the numbers by each other, then emphasize that logarithms are exponents of what? 10 in this case, and that the first two exponential law. Let's quickly look at the first exponential law of this particular logarithm. Now, the first one is you need to check you have the same base first. Let's see if it is ax multiplied by ay. When they have the same base, two things have to be considered: the base and the sign in between. Same base, put 1. Then the sign is what? Multiplication, then it will be x plus y. Basically, you have a raised to the power 3 multiply with a raised to the power 4. Basically, here, this is the base and this is the power. What is it? Is multiplication. It means the power will be added. You have 3 plus 4, and that will give me a raised to the power 7. Basically, here it means you have a, and a. That is just the implication. Then you're multiplying it with what? A, and what? A, making 4a. 1, 2, 3, 4. Then when you do all this, you're going to have what we call a raised to the power 7. But it's easier for us when you have the same base, then the sign between them, in between the base is multiplication, then the power will be added. But if it is in another case when you have a divided by a raised to the power x divided by what? A raised to the power y. Automatically here you're going to have a, but here it will be what? X minus y. What happens? The sign will change. If it is division, it will change to what? Subtraction. If it is multiplication, the power will change to what? Addition. Therefore, in this particular case, if I have a raised to the power 6 over a raised to the power 2, Basically, what this means is a raised to power 6 divided by a raised to power 2. And in this particular case, the same base, then what the operation between them is what? Division. It means the power will be subtracted, you have 6 minus 2. And that will give me a raised to power 4. That was a raised to power 4. Yes. So, since logarithm to base 10 are the exponents of what 10, we have the logarithm of the what? The numbers. If multiplying the numbers, if you are multiplying, meaning if you have log 10 to base 10 multiplied by log 100 to base 10. Basically, this will be log 10, then open bracket. Say if we had the logs of the number, if multiplying the numbers, they are multiplying. If it is plus here, then what happens here? It should be 10 times 100. And if it is division, 10 to base 10 minus log 100 to base 10. What would we say? Log 10. Then you have 10 divided by what? 100. We subtract the logs of the number if we divide the numbers by each other. Yeah, you are going to see more of this particular example when you have plus, multiply, when you have subtraction, you divide. When working out the numbers with certain power, students tend to forget why they multiply the logarithm of the number with the power. Why they multiply the logarithm with the power. Again, emphasize this exponential law since log to the base of 10 are the same as the exponent of what? 10, which we give. Well, basically what we're saying is when you have n, these are both power. Automatically, it's going to be a n times n, and that will give me what? A m n. And basically, if I have a 4 is equal to there 2 power there. If I'm going to have a 4 times 2, and that will give me a raised to power 8. Then when I have, basically when I have now a raised to power 6, automatically we need to understand that a raised to power 6, hope you close it, this square root means power of half. Means the power of half. We know if it is cube root, should be mean the power of what? 1/3. Therefore, in this particular case, it should be a, then it should be 6 times 1/2. Then invisible one here, because both of them are power. Then in this particular case, we are going to have a 2 here 1, 2 here 3, a raised to power 3. Power 3. Therefore, you need to understand that when you have cube roots, it means, for example, you have cube root of a, it means a raised to power 1/3. If we have fourth root of a, it means a raised to power 1/4. Then if I have square root of a, it means a raised to power 1/2. Good. If I have a raised to power 2 and I want to remove it and turn it to s, say square both sides. If you square both sides, this that will give you 8. if I have x raised to power 3 and I want to get my x, I'll say take the cube root of both sides. Take the cube root of both sides, I'm going to get what? X. Basically, because we know that x raised to power 3, this cube root is equal to 1 over what? 3. And in that case, you have 2 power. S will be what? 3 over 1 multiplied by 1 over 3. 3 here 1, 3 here 1. Therefore, you are going to have s raised to power what? 1 in that case. Therefore, basically, when you have s raised to power square, x raised to power 2, and you want to get your s, you what? Take the square root of anything you are given. If it is x raised to power 3 and you want to get your s, take the what? Cube root of anything you are given.